The second challenge is about animal versus human models. What do I mean by that? Most of these precision or precise neurochemical circuitries that we are talking about in amygdala or kind of the other parts of the cortex, they come from the animal studies that we do. Because with doing animal studies, we can have kind of access to these molecular levels with kind of much easier, let's say, methods, and that would make things much easier. But it is not always kind of as easy as we are talking about. For example, in the field of drug addiction, we have different levels of drug addiction. As you know, we have relapse, we have abstinence. We talk about people who are using recreational use of drugs. They could have problematic drug use, or they can just get to the level of dependency. So there are different phases of addiction, okay? And with animal models, we have different methods of studying different phases of drug addiction with animal models. So there are many different animal models that people have developed during the last couple of decades to be able to explore drug addiction from the animal model perspective. But the challenge is, as we have here, let me just kind of give you more details about that. In terms of, okay, when we talk about animal models, we can even have, let's say, within the rat brain, we still can have orbitofrontal cortex, anterior insular cortex, nucleus accumbens, dorsal striatum. All those components that we discussed about in human models, we can have them in the rat model as well. And some of these, let's say, animal model paradigms, they can engage specific areas in the brain of rat models like dorsal striatum, nucleus accumbens, shell area, central amygdala, ventral tegmental areas. All those areas, they could get involved with an animal model paradigm. And there could be also not only the area that is getting involved, but also the projection from one area to the other. So the medial prefrontal cortex to preaqueductal gray matter. So some specific projections or networks. I can tell these as something like networks. Regional activities or networks being assessed with these animal experimental models. I'm not going to give you details about these animal models, but just to give you a sense about many of those neuroscience understanding about mechanism of these disorders are coming from our animal model studies. But there is a problem here. The problem is that when we use these animal models in rats or in monkeys, trying to use these animal models and testing different medications, for example, these medications in animal models, they showed significant decrease in the level of substance use disorder. If we use these medications, animal models show that they are effective. But when people have tried them in human subjects, they were not effective. So it seems that the animal models do not have all the characteristics that we are expecting from the human model. We can have a medication which is effective in animal models in terms of reducing their substance use behavior, but when we bring that medication to the human model, they are not working. And that is a crisis that people are facing in the field of animal model studies. That, okay, I mean, we know a lot about amygdala based on the studies that we have in rat, but at the end of the day, whatever we have learned from the rat model, if you find a medication in the rat model, the medication is not going to work in most of the cases in human models. And that is the problematic part. That is the problematic part. So how we can have a, let's say, use for animal models if they are not going to give us the right information. There are people who are trying to find some new ideas for animal models. For example, this paper that was published just a few weeks ago by a really nice group of scientists in NIDA, Yavin Shaham and Marcus Halek. I have been working with them in different editorial positions too. They are really really great scientists in the field. So their idea is about reverse translation. So they have a sort of thing about, okay, instead of finding something in animal model and use that animal model in the human kind of result, or trying to use the animal findings in human subjects, let's go for reverse translation. We know that there are treatments that are effective in human models. Let's say method of maintenance treatment, or 12 steps programs, or contingency-based programs, trying to find the treatments that are effective in human models, and try to make models in animal kind of models, or trying to find a way to reflect them or represent them in the animal models, and try to understand what are the circuitries would be involved in those, let's say, treatment that are effective in human models. And you can imagine that would be complex, especially when we talk about kind of, let's say, we have 12 steps programs, or Narcotic Anonymous, or Alcoholic Anonymous programs that are effective in human subjects. How can we reflect them, or how can we reverse translate them to animal models and find neurocircuitries that are involved in these treatments? So it could be really complex. There are studies that they try to find, for example, the importance of social interactions in animal models, and the importance of social interaction in animal models in terms of reduction in substance use disorder, or reduction in the neural circuits that are activated during substance use disorder. So you can imagine the complexities of. We know that animal model studies are helpful, but how animal model studies are gonna inform us about new treatments in different mental health disorders because of the complexities of human brain, that is something questionable. So that is one of the other challenges that we have in the field, how to move from the animal models to the human models. And as a cognitive neuroscientist, I highly recommend you to have a good understanding about animal models in the area that you are working on. For example, if you are doing substance use disorder, you need to understand different types of animal models. Otherwise, it would be really hard to understand the let's say, some of the neuroscientific findings that we discussed about, because they are coming from the animal model studies. But still, there are challenges for kind of crosstalks between animal models and human models. And you can imagine that why we have these challenges. And we are hopeful that cognitive neuroscience could bridge some of those gaps in the field of neuroscience. So that was the second challenge. So we discussed about neurocircuitries as one of the first challenges. The second challenge we have discussed about animal models and the complexity of human brain in a way that it's really hard to use animal models for some of the human mental health disorders.